Measurement of distance. It is not always possible to measure the distance from any far-off objects by direct measurement. Therefore, indirect methods are used to measure the distances. The most commonly used methods are triangulation method, angular measurement method, parallax method, and reflection method. Click on the links provided. Triangulation method. Triangulation method, which is used to measure the distance and the height, is based on the geometry of a triangle. Here we construct two similar triangles and then find the distance between the observer and the object by using the properties of similar triangles. If an observer at A wants to find out the distance between him and a far-off tree at T, then he has to use the triangulation method of measuring distances. Fix two stakes at A and B in such a way that the stakes A and B and the tree are in a straight line. Construct a right angle BAC using a large carpenter's square. Measure the distance between A and C with the measuring tape. Fix another stake E such that the tree and the stakes C and E are in a straight line. Join the points. We get a right angle triangle CDE. The two triangles ATC and CED are similar. From the properties of similar triangles, we get AT by DE is equal to AC by DC. Now measure AC, DC and DE and calculate AT using the formula AT is equal to AC by DC into DE. Angular measurement method. How do we measure large distances such as the height of a mountain or the size of astronomical objects? We use angular measurement method in such cases. Let us now measure the diameter of the moon by angular measurement method. Observe the moon with the help of an astronomical telescope from a point E on the surface of the Earth. Focus the telescope on a part of the moon as shown here, and then focus the telescope on the diametrically opposite part of the moon. Measure the angle through which the telescope is moved. Let theta be the angle subtended by two diametrically opposite points A and B on the moon at the point E. Let L be the distance of the moon from the Earth. If we consider the diameter of the moon as a circular arc of radius L, then we get theta is equal to arc AB by L. Theta is equal to D by L. Diameter of the moon D is equal to L theta. If we know the distance of the moon from Earth and the angle, the diameter of the moon can be determined. Parallax method. The parallax method is commonly used to measure the distance of astronomical objects from the Earth. The illustration given here will help you to understand the meaning of parallax. Hold a pencil in front of you and look at it by closing the right and left eye alternately. What do you observe? We observe a shift in the position of the pencil with respect to the background. This shift is known as parallax. Thus, parallax is defined as the apparent shift of a body with respect to another. Let us now see how the parallax method is used to determine the distance of a star X from the Earth. Now choose a very distant star Y, whose position and direction remain unchanged even after 6 months. Find out the parallax angle theta between the stars X and Y by focusing the telescope on the star X, and then focus the telescope on the star Y. After 6 months, when the Earth reaches a diametrically opposite side, measure the parallax angle between the stars X and Y. This geometrical figure shows the positions of the stars as observed from Earth. The total angle subtended by the star X on the Earth's orbital diameter is equal to θ1 plus θ2. We know from geometry of figure that the angle subtended is equal to the arc divided by radius. Therefore, θ1 plus θ2 is equal to AB by AX. AX is equal to BX is equal to AB by θ1 plus θ2, where AX is the distance of the star from Earth and AB is the orbital diameter of the Earth. Now by substituting for AB and θ1 plus θ2, we can calculate the distance of the star X from the Earth. Reflection method. Reflection method uses the principle of reflection of waves from objects. This method is used to measure the distance of a hill from an observer, distance of the moon from the Earth, thickness of a metal sheet, depth of oceans, and it is also used to locate aeroplanes. Here we are going to discuss how reflection method is used to find the depth of oceans. Determination of the depth of an ocean. The depth of an ocean is determined with the help of sonar. Sonar uses ultrasonic waves to detect and locate objects underwater. Ultrasonic waves produced from the transmitter kept in a ship are directed towards the ocean floor. The ocean floor reflects these waves. By measuring the time interval T between the generation of the wave and reception of the echo, we calculate the depth of the ocean by using the relation S is equal to C into T by 2, where C is the velocity of ultrasonic waves.